consider a sequence of payments. So for this, let's consider a sequence of payments starting today, which we're taking to be EAT. So EAT represents today or the present. Taking today, EAT, right? So starting today, so this is the assumption I'm making. I have a sequence of payments that starts today and continues into the future. And continuing into the future. So let's consider different cases in this. We're going to start with case 1. We're going to look at the formula for this. So the case 1 is that both payments and interest rates can change over time. So this is a very generic case, the most general case we're going to look at. Then we're going to look at other cases where payments are constant over time, then cases where payments and interest rates are constant over time, and that can change over time. So this is the most generic case I will look at. We're allowing that both can change over time. So the notation that we're going to use in this case is going to be, so now this is going to represent, now this is, so ZT represents today's payment, right? The payment that you get in EAT, because EAT we've taken to be today, right? So EAT represents, so this is today's payment because EAT represents today, whereas today's payment. Now it is known today, obviously today's payment is known today. It is known today. So it does not need a subscript E, right? Which is for expectation, right? And you form an expectation of what you don't know. So it doesn't need subscript E. And then we have a ZET plus 1. Now this represents expected payment. Again, the subscript E is for the expected payment next year, right? So this is the expected payment next year. So like, let's just hold on. Let's just so this is today's payment, right? Year T, and obviously because it's known today, so you don't need a subscript T, right? And then you have right, this is expected payment next year, so you have a subscript E over here. And then you have, it is expected payment next year. This next year corresponds to T plus 1, right? Because we're taking T to be today, so T plus 1 is next year in this case, right? So if we go back, then CE to T plus 2 will represent what? CE T plus 2 will represent expected payment 2 years from today. So this is just a notation. 2 years from today. Right. So here if we try to look at this, so expected again corresponds to this E over here, and then so the color. And then 2 years from today, oh sorry, my bad. 2 years from today corresponds to this T plus 2, right? Because like we said, year T represents today, T plus 1 represents next year, T plus 2 represents 2 years from today, right? So this is just the notation and so on, right? Like ZE T plus 3 will represent expected payment 3 years from today and so on, right? So this is the notation for the payments. Now let's look at the notation for the interest rates now. So if you want to look at the notation for the interest rates now, before we actually calculate the expected present discounted value of these payments. So if we look at the notation for interest rates now, right, so okay, sorry, my bad, like this, yeah, okay, so notation is going to be IT represents the 1 year interest rate in year T, and year T represents today, right? We have written over here. So this is 1 year interest rate. So this is the 1 year interest rate. So this is the 1 year interest rate from T to T plus 1. I say this interest rate applies from T to T plus 1. Right? There are two key things to note here. It's the 1 year interest rate and it's in year T. right? So year t part, let's just quickly show it here. So in year t, and this corresponds to this over here, right? And t means today, right? Today, year t, and all that. Right, so now let's see the next thing, which is IET plus 1, right? Okay, so IET plus 1. Now this is the expected 1 year. Again, this is still a 1 year interest rate. So just an emphasis on the 1 year part. 1 year interest rate in year T plus 1. How it is the interest rate in year? So it is still a 1 year interest rate, but this is the 1 year interest rate in year T plus 1, which is next year. So this interest rate is going to apply. So this is the 1 year expected interest rate from T plus 1 to T plus 2, right? Like the 1 year interest rate in year T would apply from year T to year T plus 1. The 1 year interest rate in year T plus 1 would apply from T plus 1 to T plus 2 because it's still 1 year, right? It's just they're applying in different time spans, right? So here again, let's just look at this. So the expected part is like this, and then we have the year T plus 1 comes from here, right? So now let's look at IET plus 2. Now this is the expected 1 year interest rate again. So these are 1 year interest rates, but they're 1 year interest rates that apply in different years, right? In year T plus 2, which is 2 years from today. I'm sorry. So this is the 1 year expected interest rate from T plus 2 to T plus 3, right? And then this will be and so on. So let's just quickly look at this. So if we look at this, the expected corresponds to this E here. I'm sorry, my bad. And then this is in year T plus 2. Oh, sorry, we didn't change the color. My bad. So this is in year T plus 2, right? So basically over here, IT represents the 1 year interest rate in year T. So this applies from T to T plus 1. IT plus 1 represents the expected 1 year interest rate in T plus 1. So this applies from T plus 1 to T plus 2. Because all of these are 1 year interest rates. IT plus 2 is the expected 1 year interest rate in year T plus 2. So this applies from T plus 2 to T plus 3. So keep in mind, all of these are 1 year interest rates. This applies from T to T plus 1. This applies from T plus 1 to T plus 2. And this applies from T plus 2 to T plus 3. So let's make all of this on a timeline. So if we make a timeline here, so now this is T, and then you can write this as T plus 1, and you can show this as T plus 2, and so on and on. Right, so T, like we said, represents today or the current year, right? Right, so if I now show everything on the timeline, right? So ZT was the payment today in year T. ZT plus 1 we said is expected payment next year in year T plus 1. ZET plus 2 is expected payment in year T plus 2. Now, when I want to find expected present discounted value, I want to find the value today. So now we're going to discount these. So when you want to find expected present discounted value, you want to find the value today in year T. So we need to bring T plus 1 to year T. And discounted using IT. So this is discounted using IT to get from T plus 1 to T. Because recall IT applies from T to T plus 1. It is a 1 year interest rate from T to T plus 1. So if I want to get the expected value in T plus 1 to year T, I'm going to discount it by IT. So now what we do is now we have this ZET plus 2. So what I'm going to do is this is going to be discounted. So we're going to discount it using IE t plus 1 to get it from, because remember we want to get this payment in t plus 2 to t to find expected present discounted value, which is the value today. So we want to get first t plus 2 to t plus 1, which we're going to get using IE t plus 1, right? Because IE t plus 1, IE t plus 1 applies from t plus 1 to t plus 2. And then we're going to further, now we have this value, which was at t plus 2 at t plus 1. Now further, we're going to discount this. We're going to discount this using IT to get from t plus 1 to t. Right? So we have this value. So the whole idea is that when we're finding expected present discounted value, we want the value today in year t. T represents today for us. So the value that's already at year t does not need discounting. The value at t plus 1 needs to be brought to year t, and you're going to discount using the interest rate that applies from t to t plus 1, which is IT. The value at t plus 2, we first get it at t plus 1 using the interest rate that applies from t plus 1 to t plus 2, which is IE t plus 1. Once you have the value at t plus 1, you discount it to year t using the interest rate that applies from t to t plus 1, which is IT. Right, so now once we have this, now let's just clear this up. So the expected present discounted value of the sequence of payments is given as, right, so it's like pound BT is equal to, we said ZT is already in year T, so we don't need to discount it, right? ZET plus 1, we said we're going to discount it. We want to get it from T plus 1 to T, so we're going to discount it using the interest rate that applies from T to T plus 1, which was IT. And then ZET plus 2, we first got it from T plus 2 to T plus 1 using the interest rate that applied between T plus 1 and T plus 2, which was IE T plus 1. And then once you have it at T plus 1, you need to get it to T. So you're going to use the interest rate which is between T and T uh, plus 1, which is IT. Just keep in mind, IT applies from T to T plus 1 because all of these are 1 year interest rates. This is the 1 year interest rate from T to T plus 1, right? This is the 1 year interest rate from T plus 1 to T plus 2. So these are 1 year interest rates, but you have to see in which years they apply by looking at the subscripts. And EPD, like we said, is the value today. So now some insights. Now, what are some insights here you want to look at? Or let me just erase this, wait. I'll just quickly write this over here. Pound VT is equal to pound ZT plus ZE T plus 1 divided by 1 plus IT plus ZE T plus 2 by 1 plus IT, 1 plus IE, T plus 1, and so on. You keep on then discounting these, right? Now, some insights. Number one is the present value that we calculated. So we can see the present value depends. So the first insight is it depends positively on size of today's actual payment, which is ZT, and expected future payments. The future payments are ZET plus 1, ZET plus 2, and so on, right? We can see K. I'm sorry. So it depends positively on the size of today's payments and expected future payments, right? Right, basically an increase in Z or increase in any future ZE will increase V, right? So we can see whether we have an increase in the actual payment Z or increase in any future ZE, which is like ZT plus 1, ZT plus 2 will increase V, right? So it depends positively on these, and it depends negatively on current unexpected future interest rates. Future interest rates. Right, so that you have this relationship. Oh, sorry. Right, this is IT here, IET plus 1 here, IT here, right? So we can see over here because in the denominator, right? So we can see over, so we can see over here that an increase in I or an increase in any future IE would mean a decrease in V because they pair in the denominator, right? So the present value that you calculated depends positively on the current payment and future payments, they pair in the numerators, and it depends negatively on current and expected future interest rates, which pair in the denominators. So the last thing that you wanted, so now this was one insight. Now the second insight is, the second is when we have a sequence of payments like we had, right? We have a payment in year T, we had a payment in year T plus 1 and so on. When we have a sequence of payments, distant payments are discounted more heavily. Distant payments are discounted more heavily, right? As they are further away. As they are further away, so their present discounted value is lower. Right, we can see over here when we did not have to discount JT because it was already today. The payment in T plus 1 was just discounted by 1 plus IT. The payment at ZT plus 2 was not just discounted by 1 plus IT, it was discounted by 1 plus IT times 1 plus IT plus 1. The next payment would be discounted by 1 plus IT, 1 plus IT plus 1 times 1 plus IT plus 2. So the distant payments are discounted more heavily because they're further away. So to get them today, you need to do more discount.